In the Muslim world today, most of the focus on the relation between Islam and science involves scientific interpretations of the Quran that claim to show that the sources make prescient statements about the nature of the universe, biological development and other phenomena later confirmed by scientific research, thus demonstrating proof of the divine origin of the Quran. Although this issue received widespread support by some, it has been criticized by certain scientists as containing logical fallacies, being unscientific, likely to be contradicted by evolving scientific theories. In the Muslim world, many believe that modern science was first developed in the Muslim world rather than in Europe and Western countries, that all the wealth of knowledge in the world has actually emanated from Muslim civilization, and what people call the scientific method is actually the Islamic method. Muslims often cite verse 239 from Surah Al-Baqara, "He has taught you what you did not know," in support of the view that the Quran promotes the acquisition of new knowledge. Theoretical physicist Jim al-Khalili believes the modern scientific method was pioneered by Ibn al-Haytham, whose contributions he likened to those of Isaac Newton. Robert Briffault, in The Making of Humanity, asserts that the very existence of science, as it is understood in the modern sense, is rooted in the scientific thought and knowledge that emerged in Islamic civilizations during this time. In contrast, some people worry that the contemporary Muslim world suffers from a profound lack of scientific understanding, and limit that. For example, in countries like Pakistan, postgraduate physics students have been known to blame earthquakes on sinfulness, moral laxity, deviation from the Islamic true path, while only a couple of muffled voices supported the scientific view that earthquakes are a natural phenomenon unaffected by human activity. As with all other branches of human knowledge, science, from an Islamic standpoint, is the study of nature as stemming from Tawhid, the Islamic conception of the oneness of God. In Islam, nature is not seen as something separate but as an integral part of a holistic outlook on God, humanity, the world and the cosmos. These links imply a sacred aspect to Muslims' pursuit of scientific knowledge, as nature itself is viewed in the Quran as a compilation of signs pointing to the divine. It was with this understanding that the pursuit of science, especially prior to the colonization of the Muslim world, was respected in Islamic civilizations. Muslim scientists and scholars have subsequently developed a spectrum of viewpoints on the place of scientific learning within the context of Islam, none of which are universally accepted. However, most maintain the view that the acquisition of knowledge and scientific pursuit in general is not in disaccord with Islamic thought and religious belief. Overview. The astrophysicist Nidal Gesum, while being highly critical of pseudo-scientific claims made about the Quran, has highlighted the encouragement for sciences that the Quran provides by developing the concept of knowledge. He writes, "The Quran draws attention to the danger of conjecturing without evidence knowledge of 1736, and in several different verses asks Muslims to require proofs, both in matters of theological belief and in natural science." Gesum cites Ghalib Hassan on the definition of proof, according to the Quran being clear and strong, convincing evidence or argument. Also, such a proof cannot rely on an argument from authority, citing verse 5 to 104. Lastly, both assertions and rejections require a proof, according to verse 4 to 174. Ismail al-Faruqi and Taha Jabir al-Alwani are of the view that any reawakening of the Muslim civilization must start with the Quran. However, The biggest obstacle on this route is the centuries-old heritage of tafsir and other classical disciplines, which inhibit a universal, epistemological and systematic conception of the Quran's message. The philosopher Muhammad Iqbal considered the Quran's methodology and epistemology to be empirical and rational. It's generally accepted that there are around 750 verses in the Quran dealing with natural phenomena. In many of these verses the study of nature is encouraged and highly recommended, and historical Islamic scientists like al-Biruni and al-Battani derived their inspiration from verses of the Quran. Muhammad Hashim Kamali has stated that scientific observation, experimental knowledge and rationality are the primary tools with which humanity can achieve the goals laid out for it in the Quran. Ziad Sadar built a case for Muslims having developed the foundations of modern science, by highlighting the repeated calls of the Quran to observe and reflect upon natural phenomenon. The scientific method, as it is understood today, was first developed by Muslim scientists like Ibn al-Haytham and al-Biruni, along with numerous other Muslim scientists. The physicist Abdus Salam, in his Nobel Prize banquet address, quoted a well-known verse from the Quran and then stated, "This in effect is the faith of all physicists. The deeper we seek, the more is our wonder excited, the more is the dazzlement of our gaze." One of Salam's core beliefs was that there is no contradiction between Islam and the discoveries that science allows humanity to make about nature and the universe. Salam also held the opinion that the Quran and the Islamic spirit of study and rational reflection was the source of extraordinary civilizational development. Salam highlights, in particular, the work of Ibn al-Haytham and al-Biruni as the pioneers of empiricism who introduced the experimental approach, breaking away from Aristotle's influence and thus giving birth to modern science. Salam was also careful to differentiate between metaphysics and physics, and advised against empirically probing certain matters on which physics is silent and will remain so, such as the doctrine of creation from nothing, which in Salam's view is outside the limits of science and thus gives way to religious considerations. The religion Islam has its own worldview system including beliefs about ultimate reality, epistemology, ontology, ethics, purpose, etc. Muslims believe that the Quran is the final revelation of God for the guidance of humankind. Science is the pursuit of knowledge and understanding of the natural and social world following a systematic methodology based on evidence. It is a system of acquiring knowledge based on empiricism, experimentation and methodological naturalism, as well as to the organized body of knowledge human beings have gained by such research. Scientists maintain that scientific investigation needs to adhere to the scientific method, a process for evaluating empirical knowledge that explains observable events without recourse to supernatural notions. History. Classical science in the Muslim world. In the history of science, science in the Muslim world refers to the science developed under Islamic civilization between the 8th and 16th centuries, during what is known as the Islamic Golden Age. It is also known as Arabic science since the majority of texts during this period were written in Arabic, the lingua franca of Islamic civilization. Despite these terms, not all scientists during this period were Muslim or Arab, as there were a number of notable non-Arab scientists, as well as some non-Muslim scientists, who contributed to scientific studies in the Muslim world. A number of modern scholars such as Fielding H. Garrison, Abdus Salam, Sultan Bashir Mahmud, Hossein Nasr consider modern science and the scientific method to have been greatly inspired by Muslim scientists who introduced a modern empirical, experimental and quantitative approach to scientific inquiry. Some scholars, notably Donald Rutledge Hill, Ahmad Y. Hassan, Abdus Salam, and George Saliba, have referred to their achievements as a Muslim scientific revolution, though this does not contradict the traditional view of the scientific revolution which is still supported by most scholars. Certain advances made by medieval Muslim astronomers, geographers and mathematicians were motivated by problems presented in Islamic scripture, such as Al-Khwarizmi's development of algebra in order to solve the Islamic inheritance laws, and developments in astronomy, geography, spherical geometry and spherical trigonometry in order to determine the direction of the Qibla, the times of Salah prayers, and the dates of the Islamic calendar. The increased use of dissection in Islamic medicine during the 12th and 13th centuries was influenced by the writings of the Islamic theologian Al-Ghazali, who encouraged the study of anatomy and use of dissections as a method of gaining knowledge of God's creation. In Al-Bukhari's and Muslims' collection of Sahih Hadith it is said, "There is no disease that Allah has created, except that He also has created its treatment." This culminated in the work of Ibn al-Nafis, who discovered the pulmonary circulation in 1242 and used his discovery as evidence for the orthodox Islamic doctrine of bodily resurrection. Ibn al-Nafis also used Islamic scripture as justification for his rejection of wine as self-medication. Criticisms against alchemy and astrology were also motivated by religion, as orthodox Islamic theologians viewed the beliefs of alchemists and astrologers as being superstitious. Fakhruddin al-Razi, in dealing with his conception of physics and the physical world in his Matalib, discusses Islamic cosmology, criticizes the Aristotelian notion of the Earth's centrality within the universe, and explores the notion of the existence of a multiverse in the context of his commentary, based on the Quranic verse, "All praise belongs to God, Lord of the worlds." He raises the question of whether the term worlds in this verse refers to multiple worlds within this single universe, a cosmos, or to many other universes, or a multiverse beyond this known universe. On the basis of this verse, he argues that God has created more than 1,000 worlds beyond this world, such that each one of those worlds be bigger and more massive than this world, as well as having the like of what this world has. Al-Qasqu's support for the Earth's rotation and his rejection of Aristotelian cosmology was motivated by religious opposition to Aristotle by orthodox Islamic theologians, such as Al-Ghazali. According to many historians, science in the Muslim civilization flourished during the Middle Ages, but began declining at some time around the 14th to 16th centuries. At least some scholars blamed this on the rise of a clerical faction which froze this same science and withered its progress. Examples of conflicts with prevailing interpretations of Islam and science, or at least the fruits of science, thereafter include the demolition of Taqi al-Din's great Istanbul Observatory of Taqi al-Din in Galata, comparable in its technical equipment and its specialist personnel with that of his celebrated contemporary, the Danish astronomer Tycho Brahe. But while Brahe's observatory opened the way to a vast new development of astronomical science, Taqi al-Din's was demolished by a squad of Janissaries by order of the Sultan, on the recommendation of the Chief Mufti. Sometime after 1577 AD, arrival of modern science in the Muslim world at the beginning of the 19th century. Modern science arrived in the Muslim world, but it was not the science itself that affected Muslim scholars. Rather, it was the transfer of various philosophical currents entangled with science that had a profound effect on the minds of Muslim scientists and intellectuals. Schools like positivism and Darwinism penetrated the Muslim world and dominated its academic circles and had a noticeable impact on some Islamic theological doctrines. There were different responses to this among the Muslim scholars. These reactions, in words of Professor Mehdi Golshani, were the following. Decline. In the early 20th century, Shia ulama forbade the learning of foreign languages and dissection of human bodies in the medical school in Iran. In recent years, the lagging of the Muslim world in science is manifest in the disproportionately small amount of scientific output as measured by citations of articles published in internationally circulating science journals, annual expenditures on research and development, and numbers of research scientists and engineers. Skepticism of science among some Muslims is reflected in issues such as resistance in Muslim northern Nigeria to polio inoculation, which some believe is an imaginary thing created in the West, or it is a ploy to get us to submit to this evil agenda. Muslim Nobel laureates. The relative lack of Muslim Nobel laureates in sciences in comparison to the population has been attributed to more insular modern interpretations of the religion, in comparison to how in the Middle Ages it was open to foreign ideas. However, 6 predominantly Muslim countries had more Nobel laureates per capita than e.g. Brazil, India and China. India is 68th out of 72 countries in Nobel laureates per capita, China is 69th, and Brazil is 72nd. The 70th and 71st places are occupied by predominantly Muslim countries. The relative lack of high-ranking universities can be observed in most non-Western and newly industrialized countries, with exceptions in Japan, South Korea and Hong Kong. Islamic attitudes toward science. Whether Islamic culture has promoted or hindered scientific advancement is disputed. Islamists such as Saeed Qutb argue that since Islam appointed Muslims as representatives of God and made them responsible for learning all the sciences, science cannot but prosper in a society of true Muslims. Many, classical and modern, agree that the Quran condones, even encourages the acquisition of science and scientific knowledge, and urges humans to reflect on the natural phenomena as signs of God's creation. Quote, some scientific instruments produced in classical times in the Islamic world were inscribed with Quranic citations. Many Muslims agree that doing science is an act of religious merit, even a collective duty of the Muslim community. Others claim traditional interpretations of Islam are not compatible with the development of science. Author Rodney Stark argues that Islam's lag behind the West in scientific advancement after 1500 AD was due to opposition by traditional ulama to efforts to formulate systematic explanation of natural phenomenon with natural laws. Quote, he claims that they believed such laws were blasphemous because they limit Allah's freedom to act as he wishes, a principle shared in Ayah 14-4, Allah sendeth whom he will astray, and guideth whom he will, which applied to all of creation, not just humanity. Abdus Salam, who won a Nobel Prize in physics for his electroweak theory, is among those who argue that the quest for reflecting upon and studying nature is a duty upon Muslims, stating that 750 verses of the Quran exhort believers to do so. Science in the Quran and Hadith. The belief that the Quran had prophesied scientific theories and discoveries has become a strong and widespread belief in the contemporary Islamic world. These prophecies are often offered as evidence of the divine origin of the Quran. See scientific foreknowledge in sacred texts for further discussion of this issue. Bucay in 1976. Morris Bucay published his book, The Bible, the Quran and Science, which argued that the Quran contains no statements contradicting established scientific facts. Bucay argued that the Quran is in agreement with scientific facts, while the Bible is not. He states that in Islam, science and religion have always been twin sisters. According to Bucay, there are monumental errors of science science in the Bible and not of single error in the Quran. Bucay's belief is that the Quran's descriptions of natural phenomena make it compatible with modern science. According to the Wall Street Journal, Bucaism is in some ways the Muslim counterpart to Christian creationism. Although, while creationism rejects much of modern science, Bucaism embraces it. It described Bucaism as being disdained by most mainstream scholars, but said it has fostered pride in Muslim heritage and played an important role in attracting converts. Tana Edis wrote an illusion of harmony, science and religion in Islam. Eddy worries that secularism in Turkey, one of the most westernized Muslim nations, is on its way out. He points out that Turkey rejects evolution by a large majority. To Edis, many Muslims appreciate technology and respect the role that science plays in its creation. As a result, he says there is a great deal of Islamic pseudo-science attempting to reconcile this respect with other respected religious beliefs. Edis maintains that the motivation to read modern scientific truths into holy books is also stronger for Muslims than Christians. This is because, according to Edis, true criticism of the Quran is almost non-existent in the Muslim world, while Christianity is less prone to see its holy book as the direct word of God. Few Muslims will compromise on this idea, causing them to believe that scientific truth simply must appear in the Quran. However, Edis opines that there are endless examples of scientific discoveries that could be read into the Bible, the Quran, if one would like to. Edis qualifies that Muslim thought certainly cannot be understood by looking at the Quran alone. Cultural and political factors play large roles. Conception and inherited characteristics. Islamic sources like the Quran and Hadith emphasize the role of God as a creator, and thus frequently refer to the creation of new individuals. Medieval Muslims relied heavily on their own scientific tradition to interpret these statements, which vary in explicitness and clarity. The most prominent of the ancient Greek thinkers who wrote on medicine were Hippocrates, Aristotle, and Galen. Hippocrates and Galen, in contrast with Aristotle, wrote that the contribution of females to children is equal to that of males, and the vehicle for it is a substance similar to the semen of males. Bassem Musalam writes that the ideas of these men were widespread through the pre-modern Middle East. Hippocrates, Aristotle, and Galen were as much a part of Middle Eastern Arabic culture as anything else in it. The sayings in the Quran and those attributed to Muhammad in the Hadith influenced generations of Muslim scientists by siding with Galen and Hippocrates. Bassem Musalam writes, The statements about parental contribution to generation in the Hadith paralleled the Hippocratic writings, and the view of fetal development in the Quran agreed in detail with Galen's scientific writings. He reports that the highly influential medieval Hanbali scholar Ibn Qayyim, in his book Kitab al-Tibyan fi Aqsam al-Quran, cites the following statement of the Prophet when asked the question, "From what is man created?" Modern Hadith scholars and some early ones consider the chain of transmission of this Hadith to be weak. Creation and evolution. The Quran contains many verses describing creation of the universe. Muslims believe God created the heavens and earth in 6 separate eras. The earth was created in 2 eras, and in 2 other eras God furnished the creation of the earth with mountains, rivers and fruit gardens. The heavens and earth formed from one mass which had to be split. The heavens used to be smoked and form layers, one above the other. The angels inhabit the seventh heavens. The lowest heaven is adorned with lights, the sun and the moon, the stars and the constellations of the zodiac. A majority of Muslims are at odds with current scientific theories about biological evolution and the origin of man. According to a recent Pew study, large fractions of Muslim countries do not accept that humans have evolved over time. For instance, a relatively large fraction of people accept human evolution in Kazakhstan and Lebanon, but relatively few in Afghanistan, Iraq, and Pakistan, with most of the other Muslim countries somewhere in between. The late Ottoman intellectual Ismail Veni, while personally rejecting Darwinism, insisted that it should be taught in schools as even false theories contributed to the improvement of science. He held that interpretations of the Quran might require amendment should Darwinism eventually be shown to be true.